So I'm Hamish, but a lot of people like to call me 25 bacteria. Let's get started. O, aka Nile River Soldier. Let's get started. So now we're going to check some of the kinetic energy, velocity, vector, scalar, quantity, velocity, time graph. We have some questions here, and we don't want no waste time. Let's get started. So now let's see. Let me start for the last one so I can have a space and then go up. Which of the following bodies, the bodies mean the object, okay, has the largest kinetic energy? So you won't be able to answer this question if you don't know what this kinetic energy means. Let me break down for you in 1 minute. Kinetic energy, little form, kinetic energy equal to a half mass times velocity squared. You memorize this, okay? You don't have to work it out, just memorize. So if I want to get kinetic energy of any objects, that object must have a mass. How do we measure mass? Mass, always the unit of mass is kilogram. Like when you go and buy rice, you know, I like rice, I'm saying chicken. So you go and buy rice, they say, oh, half kilogram, though, so that's a mass. 2 kilograms, that's a mass, okay? You know what I'm saying? So for you to get kinetic energy, you must have a mass. And then you must have a certain velocity. So like for example, this stuff, if I want to take this out, put in the scale, it's going to have some weight, mass. It does have a mass, maybe 0.0 gram or whatever, you know what I'm saying? But if it's standing there, it's not moving. If it's just here, it's standing, it's not moving, means it doesn't have a kinetic energy. You know why? Because this velocity is going to be 0. So it's going to be a half times mass, our mass, let's say 1 kilogram, times velocity, since it's not moving, means it's going to be 0 squared. You know what I'm saying? Means the kinetic energy is going to be 0 because 0 squared is 0 times mass is 0 times a half 0. So no kinetic energy. So for you to have a kinetic energy, you need to have two things. That object must be moving and that object must have a mass. Otherwise, no kinetic energy. You know what I'm saying? You get what I'm saying? So now let's come to this question. So you need to have a mass and velocity to find the kinetic energy. For example, somebody say, Hamish, Nile River Soldier, I was running, you know what I'm saying? I was flying, you know, in the area of Nile River, you know that's the longest river now, Nile River Soldier. So now Hamish had a mass, okay, my man, now I'm already so high. Okay, my mass, right now I think I'm in 89 or 90 kilograms, but let's just make 89 kilograms. That's my weight, I'm a big man, you know what I'm saying? Now, and I was running at the velocity of 2 meters per second. That's my velocity. Now, let's find the kinetic energy. So kinetic energy equal to a half. What is my mass? My mass equal to 89 kilograms times velocity. Velocity equal to 2. By 2, we say velocity square. So velocity square. Oh, so now we can get it. Easy. So I'm going to say now, a half times 89 times 2 square. 2 square equal to 4. So this is going to give us 4. So equal to a half times 89 times 4. By 2, 1, how many 24? There are 2. You can put in calculator. This is going to give you okay, 180. Okay, forget a calculator. I think 178. But you can just probe 9 times 2, 180. Yeah, 178. But the unit of energy, kinetic energy, is joule. So my kinetic energy equal to 178 what? Joule. You know what I'm saying? So a half times mass times velocity. Now let's go to this question. Now let's say which of the following has the largest kinetic energy. So we're going to calculate it one by one and see which is going to give us the largest kinetic energy. Okay, cool. Now let's start for the first one. So we're going to calculate it one by one and they're going to write here. Like right there. Okay, now let's start for the first one. Number one. So we say kinetic energy, let's say kinetic energy 1 equal to a half times mass. What is my mass here? 3m. So they didn't give us like, they kind of give it a puzzle way, like, you know, like they don't give it like actual. So instead of saying mass, I'm going to say 3m. Okay, and then velocity. What is the velocity? They say velocity is 2v. So instead of this velocity, I'm going to replace this velocity by 2v. So I'm going to say 2v, but remember, it must be square. Square. Oh, okay. So then after now, we're going to say this is same as say, now we can square this mathematically. 2 square equal to 4, v square is going to be 2. 2 square equal to 4, v square. Okay, so now I'm going to have a half 3m. Okay, 2 square equal to 4 times 4 and then v square. So now this by 2, 1, how many 24? 2. So here I'm going to have a 2 times 3 equal to 6. So this is going to give me 6. M is m. And they have a v square. Oh, so the first one, the first option is going to be let's call kinetic energy 1 equal to 6mv squared. 6mv squared. Now let's go for the second one. So for the second one, and then we're going to check which is going to give us the highest, whatever you have there, kinetic energy. So now we're going to do for the second one. Okay, so we're going to use the same formula. I have the VMV square. So I have, what is the mass for the second one? Mass equal to 3m. 3m. Now we go for V. What is the V? For V equal to V. So here is going to be bracket. Make sure you put bracket. Instead of say V, I want to put 2V because the 2V. Now we say square. Okay, so this is going to give us, okay, we have a half times 3m. Okay, 2 square equals 4. And this is going to be V square. Okay. By 2, 1. By 2 is going to be 2. You know what I'm saying? Now 2 times, did I do the same question? Or did I copy the same question? My apologies. Let me just check quick if I did copy this question correct. Okay. Just a second, guys. Oh my God. So the first one is just a V. No problem. So we're going to replace. So this is going to be 2 times 6 equal to 2 times 3 equal to 6 mv squared. M equals mv squared. So the kinetic energy 2 is correct. 6mv squared. So kinetic energy 1, it was just a V. You know what I'm saying? So since just a V, let's do it again quick. Let me go quick now, right? Because you understand what is happening. So kinetic energy equal to a half mv squared. So what is the m? M equals 3m and v. So instead of say v here, we're going to still say v squared. So now this is going to give us 1 over 2. Now, so it's going to be times 3m times v squared. Okay, so now this is going to be 3 times 1 is 3. Okay, over 2 mass v squared. You know what I'm saying? Here we go. So we got it. So now the first option was wrong. It has to be 3 over 2. So this must be 3 over 2, 3m squared. So this 3 over 2. Okay, now let's go for the next one. Okay, so now we go for question number, which question? Oh, number 3, the 3 one, I want to check. Okay, now let's take the 3 one. How it's going to give us as far as kinetic, and then we're going to check the largest one, because according to the question, it's the largest kinetic energy. So a half mass. What is the mass for 3? Mass equal to m times v equal 3v. So instead of say v, I'm going to say what? 3v per square. So this is going to give us a half, just a half. M to m is 2m. To m, and then multiply 3 square equal to 9, and this is going to be v square. Now we go by 2, 1 by 2, 1. You can use the calculator if you want, but 2 divided by 2, 1. So it's going to be 1 times m is m times 9 is going to be 9mv square. So this is going to give us 9mv square. So kinetic energy 3 equal to 9mv square. So long 3 is leading, because 3 over 2 is 1.5. 3 over 2 is 1.5. So the 3 for so long is leading. Now let's go for number 4. So number 4. Okay, number 4, kinetic energy 4 equal to a half mv squared. What is the m? Our m equal to 2m. And then, no, m equal to m, number 4. Okay, accuracy. Okay, and then times 4v per square. You know what I'm saying? So now this equal to a half m, 4 square equal to 16. And this is going to be v square. Okay, by 2, 1, and then by 2 is going to be 8. So it's going to be 8mv square. This is going to be to 8mv square. So kinetic energy 4 equal to 8mv square. Now we want to go for the last one. So let's say all the above have the same kinetic energy. No, it's not. It's not true. So we know number 3 is true. So option 3 has the largest kinetic energy, and the smallest kinetic energy is option 1. So it depends on the question I was going to ask you. But for this case, my option is true. It is option 3. So this is my answer here. So we're done with this question. Let's go up. Okay, let's go up. So you see we have a space now. You know, so, that guy asked good night. It's a 90 kilogram. Oh yes. Saying I've been exercising a lot. You know what I'm saying? Eat a lot. I like chicken rice, man. Chicken rice, spaghetti. You know, fruits. And I like pizza too. Avocado, fruits, you know what I mean? Exercise. You know, it's stuff. Because I want to do boxing and wrestling. You might see me sometime doing some wrestling. Let's go question number 4. Question number 4, we go. Okay, so let's talk about the vector. Which one is vector? So first and foremost, you need to understand what is vector. Vector always it shows direction. Okay? For example, wind. So we got 2 types of quantity. There's the vector quantity and scalar quantity. Let's start with the scalar quantity, vector quantity, so it can make a lot of sense. Vector quantity. So what is vector quantity? Vector quantity is something which has a magnitude and direction. What is magnitude, my man? Magnitude, look, for example, if you have a force, okay, this is me right here, right? Oh, that's you. Let's say this is you. You know what I'm saying? I'm gonna draw you ugly. You know what I'm saying? That's you. You know what I'm saying? So you kind of push this box here, okay? You have a box here. So there's a big box here, you pushing. You push you now. You know what I'm saying? You ugly as hell. I'm just draw for fun. You know what I'm saying? So that's you. You push this one. So when you push means you use a force. So when you push, use a force you always use. We use Newton. Whenever you use a force, it means the unit of force is Newton. So let's say you use 3 Newton to push this box. So this box is gonna go that direction. So this 3 Newton, we call it magnitude. So magnitude is this unit here. I'll say unit. I'm gonna give it an easy way so you can understand, like unit of something. For example, another thing, let's say wind. So this is magnitude here. Magnitude. Magnitude. But what is direction? It go to the right or it go to the east. So the direction is east. So vector quantity, it always has magnitude and direction. And that is vector quantity, it's magnitude, and then it must have also direction. If it does not show, then it's not vector quantity. Okay, for example, let's say wind. Oh, the wind, you know those people in news say, oh, the wind was blowing south, they see, okay? So if the wind is blowing, let's say to the north. But how does the wind blow? The wind, when it blows, means there's a velocity it has to, because it moves, so it uses velocity. So this wind, it was blowing, you know what I'm saying? Or whatever you can say, you know, I don't have a good word sometimes. Using velocity, because if the wind blowing, whatever, you know what I'm saying, means you use velocity. So velocity, that's a magnitude. But in which direction? It was blowing to the north. So that north is the direction. So this velocity was blowing, but okay, how does it blow? Must be velocity. Let's say 100 meters per second. So this is magnitude. But which direction? Oh, it was going northeast. Oh, so it's going northeast. Oh, so this northeast is the direction. So wind, it is a vector quantity. You know what I'm saying? Now let's take all this stuff here. They say, what the question? They say, oh, okay, displacement. Whenever you say displacement is a distance, but that distance must have a specific direction. For example, you say from, let's say Nigeria to Tanzania. So, you know what I'm saying? But it's, let's say from Nigeria, Tanzania, west to east, means West Africa to East Africa. Means there is a distance, and then you specify direction. Then that's what we call displacement. So displacement is same as a distance, but the difference is displacement must show direction. But when you say Tanzania, Nigeria, means you not specify the direction, so that means the distance. Or when you say, let's say Congo to Egypt, Congo, let's say from Congo to Egypt, means you don't specify direction. But when you say moving from Kenya to South Africa, or South Africa to Kenya, south to east means you specify direction. So when you specify, when you say distance with the direction, that's a displacement. You know what I'm saying? So now let's see among these which is not vector. Now let's go to the mass. You know how we measure mass? Whenever you go to the shop or whenever you buy something, you know what I'm saying? When they say, oh, 2 kilograms. So that's a mass. But come on, if you have a bag of rice, this is a bag of rice. Does it say anything with the direction? No, it's just a bag of rice, 1 kilogram. You know what I'm saying? So it does not say like, oh, this bag of rice, blah, blah, blah. So for me, I'll say this is not vector quantity. Even though it has a magnitude, which you measure using kilogram, but it does not specify direction. Displacement, we know. We say displacement is the distance, but it must show the direction. Now we go to the weight. Weight means force. Weight and force is the same thing. So when you say, oh, me, personal, I exert a force which vertical downward to the earth. You know what I'm saying? We call force of gravity. Force of gravity. So it means, but okay, so I have force, me, for example, me, I say, okay, my force of gravity, because force of gravity, which is exert vertical downward, you must take mass times gravity. But what is my mass? For example, now my mass is 89. Yeah, I gained some pounds, man. I used to be 82, 83. So 89 kilogram. but you must multiply by the gravity. So what a gravity is 9.8. Any object exerts a force down to the earth. So I'm going to say, 89 mass times gravity, 89 times 9.8. And the gravity always constant. So these, okay, let's say 90 for 5 times 9.8. So when you multiply this one, you're going to get something. And this is going to be my force. Or you can say my weight. So weight and mass is two different things. You know what I'm saying? So my force of gravity is exert downwards. Means it has a direction. Where? Downward. You know what I'm saying? If I throw this pen up, means the force is going to exert, okay, never mind. It's going to exert down, but which direction? Even though it's moving up, but it's not for the day. We don't want to go for the force. So for now, we want to know, okay, weight, it does have a magnitude, which is Newton, and direction depends where your force exert. Like here, you pushing here with the force. Which direction? To the east. So yes, it's the vector quantity. Now let's call acceleration. Acceleration, oh yes. You know why? Because you get acceleration by saying acceleration equal to velocity over time, changing velocity over time. So when you say velocity, already you have specified. Velocity means like a speed, but it must have a direction. You know what I'm saying? So velocity is the speed, but that speed must show direction. So now another thing. So acceleration is a vector. Force is the same thing. Oh, similar. Force is almost similar to the weight. Now I'm saying friends, like twins. You know, just something quick I want to say. Okay, how if it was speed? That's my question. Sometimes they ask you speed. What about speed now? I want you to predict speed. Is it vector or not? Speed. Speed is not vector. It's just a scalar quantity. You know why? Whenever you say speed, it does not show direction. But when you say velocity means it must be with the direction. Like the wind was blowing, but which is blowing? Northeast. Okay? So speed, let me say that slow. Okay, so speed, just speed alone, you can say 4 meters per second. But when you say 4 meters per second to south, then that's not speed anymore. That's the velocity. You know what I'm saying? You see the difference? So with the velocity, you must show the direction. You must specify. Velocity means you must specify which direction. Let's say south or east. So whenever they say speed, just know that's the velocity, but it's specified direction. I think you're gonna say this part here. So for this case, mass is not vector quantity, it's a scalar quantity. It only has a magnitude, but it does not have a direction. Let's go to question number 3. Okay, I gotta go quick now, man. Finishing up. Okay. People talk about the area under the graph time graph. The area under velocity time graph. Okay, let me explain to you quickly what area time graph and how you get it. Because sometimes this don't make sense. It makes sense, but they're not gonna ask something like that all the time. They're gonna want to, play with your mind. Okay? Now, let's say for example, let's say this is a building. This is a building here. Okay, you went for your own craziness. I don't know what you were doing. You went to the top of the house, top of the roof. It's you now again. You know what I'm saying? So he's trying to do some of your madness, So, so now you decide now. You say, you know what? I want to jump. People say, oh, come on, don't jump. Come on, what do you want to do then, man? You decide, okay, I'm not going to jump now. I'm going to drop the ball. So you decided to drop your ball. So when you drop your ball, when you drop, there's difference between when you drop and you throw. When you drop something, means your initial velocity equals to 0. Means initial velocity equal to 0 when you start it, when you drop it. And this ball, now you drop it, this ball is going to go. What happened? Means velocity is going to increase. So when it reaches the floor, what happened? Velocity final, let's say it's 4 meters per second. Okay, 4 meters per second. Here, let me say something. Some people don't know what this means. Okay, unit of velocity is meter per second. But sometimes we can say this is meter, but second is like say second. If you say 3 and 3 power 1 is the same thing. So it's like second power 1. But if you can reciprocate this to the top, this is going to become ms power -1, because this can go to the top and the only thing you change is the sign. So you can write it this or you can write it this. Either one. This is a unit of velocity or speed. That's why you see me, I'm writing like this. You know what I'm saying? So velocity final got 4. So come on, let's think about it, guys. If you drop this ball and this ball goes to the floor, is it going to stack there like magnet? It's not going to stack like magnet. It's going to bounce and go up. Okay. So this ball, when it bounces, is going to go up again. You know what I'm saying? It's going to go up. So if it's going to go up, the velocity is going to kick here. It might be same or slightly less when it goes up. You know what I'm saying? But this is not, okay, let's say it went up again. Okay, so the bouncing velocity, you think it's going to be the same or it's going to decrease? Because it's going to come and then it's going to go up. But when it goes up, maybe somewhere here, it's going to go somewhere here and then it's going to turn again. So let's say it goes up. Let's say it goes up by, because this velocity is going to be the same thing, it's going to go up. It's going to be 4 meter. And then when it meter 4, it's going to go by the opposite direction. And then when we reach here, it's going to become velocity final equal to 0 because it can't go farther. It's going to have to turn. Means velocity finally became 0 for the second party. And the ball goes down. If it goes down, it's going to go a little, etc., etc. Okay, now. So we want to draw a graph of velocity and time. Let's say initial, this guy, when he dropped the ball, it took him 2 minutes. But when this ball goes up here, it took him, let's say 3 minutes. And then 1 minute. So we want to draw a velocity time graph. Okay, now let's draw rough sketch. Okay, so now we're going to say, this is time and this is velocity. Now, initial, this guy dropped the ball. So when you drop the ball, what is the velocity? This is velocity, remember, right? This is a velocity, and this is time, velocity meter per second, and this is time per second. So when you drop the ball, initial means you don't have no velocity because this ball, it was at rest. It's like a drop. You not throw, you drop. Means initial velocity equal to 0, velocity initial equal to 0. Even though it look like it goes down, so you have to pitch in two things. It's a ball and it's a graph. So if you have a ball here, you drop the velocity 0, but what happened? The velocity is going to increase, it's going to increase, it's going to increase, and it's going to increase to velocity 4. But remember, time also is moving. If I'm running, means also time is moving. So now we say, oh, so now this velocity increased to 4. So the velocity, it was 0, it increased to 4. But remember, what happened? Time also is moving. So even though it came to 4, but time also is moving. For how many minutes? 2 minutes. Time is 2 minutes. But so it's not going to go like this, it's going to go like this. You know why? Because time also is moving. So this speed is going to increase to 4. But why am I drawing like that? Because time also is moving. So here is right here. You know what I'm saying? So, and then, okay, let's say, and then after that, this guy went up. So what happened means he changed the direction. Or, I don't want to go farther. Okay, let's stop here for this case because this question is just a basic question. And then I'll make another video. I actually have another video for velocity time graph. Let's answer this question. So for this case here, okay, so I'm done. I'm stopping here. I'm stop here. So this is the velocity time graph. And now another thing, if you want to get acceleration, acceleration always equal to change in velocity over time. In other words, velocity final minus velocity initial over time. So acceleration always change in velocity. What is velocity final? Velocity final was 4 minus velocity initial. What is initial? It was 0. Over how long did the guy take? It take 2 minutes. So acceleration equal to 4 over 2. And this is going to give us 2 meter per second. But for acceleration, I must put -2 here. Or you can say 2 meter over second. Meter per second square. You know what I'm saying? So the area under the velocity time graph represent acceleration. Why? Because acceleration equal to velocity over time. So what I explained is now part of it, but I just want to show you like what is the velocity time graph, so you can have just a little understanding of it. So we're done with the second question. With the third question, let's go to question number 2. This is an easy question. So question number 2 is very easy, man. So before I get started, I can just draw some stuff for you here, man. Very formula, simple formula. You should memorize these formulas, man. You really have to. Formula. Okay. Velocity, equation of motions. Means these are about motions of objects or whatever. You have particle or objects. So we have like a lot of them. Some books they write a lot of complication. I'm going to give only 3 questions. Any of these type of question you can solve it. So the first question, you say V equal to U plus AT. Is a final velocity, and this initial velocity, final velocity. This initial, and this is time, and this acceleration. You know what I'm saying? Let me say this. Excuse me. So this is the final. You can say the final. Oh my God. Let's go. V final, and this is V initial plus AT. But this is for horizontal motion. Let me say horizontal motion. Like this type of motion. You know what I'm saying? Horizontal motion. Okay? Another one, you say distance, but since the horizontal, you know horizontal something with the X, like this. So distance, let me write general. Distance equal to velocity initial times time plus a half AT squared. Come on guys, this is easy, man. You just memorize. The last one, let me show you how to memorize the last one. You see this one? Squared. You see this one? Squared. Velocity initial square. And the plus here, make sure you write 2 before. And the ratio A. And then this is T, right? Here write distance. It's a distance, and this is a distance also. Meaning distance. And this is distance, this is acceleration, this is velocity initial, velocity final. Memorize this, please, please, please memorize. Okay, so why do you say horizontal motion? So for vertical motion, for vertical, it's the same thing, but the only thing you represent, you replace this by G. You replace this by G. You put G, gravitational, because any motion of objects or particle, which either moving vertically down or vertically up, we use gravitational force because it's always under influence of gravitational G. G. You know, so we represent this by G if it's vertical, so you represent by G. But for horizontal motion, if let's say I throw the ball, so what happened? I'm not going to use A, I'm going to use G, which is 9.8. And it's always constant, it's 9.8. G is 9.8. But for A, it always change. But for G, it's on 9.8. Now, so now we're going to take our information and we're going to see this is going to be vertical or horizontal. So our data is going to tell us like which equation should I use. Okay? Now let's go. Are the instant traffic lights? Okay. Are the instant traffic lights? Okay. Okay, let's say this is traffic lights. See? Traffic lights somewhere here. Okay. I don't know how to do well. Okay. Turns green. So you decided turns green. Okay. It turns green. You say, yeah. Turns green. Means you can go. Okay, so a car's been waiting at an intersection. Means here at the intersection. Maybe there's a road. Car's been waiting here. This is a small car. Let's say car. Just a car. Been waiting at the intersection with a constant acceleration, like. So it want to accelerate, like. So that's acceleration. What is acceleration? Our constant acceleration equal to 3.2 meter per second. Okay. At the same time, at the instant track, big truck is coming now behind, travel with a constant speed of. So there's a track also, travel with a constant speed of 20. So there's another track. So what is this track going to do? It came and then overtake and pass the car. So this truck, it just came here. Big truck, okay? And then came and overtake. So let's say it overtake this, means instant at this distance. And then overtake and passing the car, so this car is still there, accelerate like it's in the same place. Just waiting for so the green light say on. This guy just came and then he just started overtake. And then what happened? with a constant speed. Oh, so we have a speed of a car which equal to 20.0 meter per second. And then overtake passes the car. How far beyond its starting point does the car overtake? Okay, so this car, this is starting point where is the traffic. So they say how far this car is gonna come and overtake the truck. So even though this truck went further and overtake, and let's say it covered, but this car is gonna, no, you can't overtake me, man. It came and then it passes the truck. Let's say at this point, let's say this is a point to it. The car came and overtake a truck. Is a car. So remember, when this car come and overtake traffic, means overtake a truck, they're gonna cover the same distance. Because this one was, it overtake, but it was not too fast. But when this one come and then overtake, means they're gonna cover same distance where the car is gonna come and overtake the truck. Now, they say how far, so we wanna find the x. So now what I'm gonna do, you see the data I have a data for car, small car, and I have a data for truck. So now, I gotta be clever now, okay? So if I say for the car, what do I have? Initial velocity was 0. Because it was like standing, but it was only accelerate. Accelerate is like, it's not moving, but it can't accelerate. You know accelerate of a car? Okay, so initial velocity was 0, but acceleration we had 3.2. Distance covered? No, we don't know distance covered. Okay, velocity final, we don't know where the car came and overtake the truck. We don't know velocity final. Now, let's come for the truck. But for the truck, we have a velocity constant. This is not about initial or what, because this one when it came woo, at this traffic light. Means we had a velocity of the car, just a velocity, not initial final, just velocity constant, which equal to 20 meter per second. And distance covered, we know. Distance covered, because its velocity is going to be constant from beginning to an end. So the distance covered is going to be the same as that. So here I have more information. So I think I can use this to take on my advantage. So I'm going to say, okay, so now I have an initial velocity, acceleration, distance. I'm going to come here and see which I'm going to use. Do I have final velocity for the car? No, I don't have. Initial velocity of a car? Yes, I do have. Okay. Acceleration do I have? Yes, I do have. Time do I have? I don't have. So I don't have velocity final and time. And you don't want to involve with something which I've got 2 unknown for now. Let's check out the option. Velocity initial is 0 for car. Okay, I'm focusing for car. Time taken? No. So 0 times anything is 0. So everything here is going to be 0. Now we come here a half. Acceleration do I have for the car? Yes, I do have. I have. Time taken? No, but I can use this to get distance. Because this is distance that we're looking for. So you can say X or Y or S. Okay, so distance covered by car, let's say by car, equal to initial velocity of a car, 0. So it's going to be 0 times t, 0. So I can say 0 plus a half. Acceleration I have 3.2. Time taken for a car, we don't have time taken. So let me call this first equation. But 3.2 divided by 2 equal to 16. So distance covered by car, by C car, equal to 1,6 t squared. So let's call this first equation. So the problem, I don't have a time. You know, but I can use this track now to get time. How I'm going to do that? Remember, for a track, I don't think it's good to use none of this, because the velocity does not specify initial, final. It just a constant velocity. So we're going to use the basic formula, the one we learned in grade 5, 6, 7, 8. Velocity equal to distance over time. Like normal, velocity over distance over time. So for the track, we have velocity. Velocity we have, which is 20. So this is track. Velocity we have, velocity we have, what is the velocity? 20 for track, which is constant. Distance is going to be the same distance as this. So distance, I can say, okay, let's say distance is going to be the same. Over time taken, times, is time going to be the same? If time, yeah, same time. Because look, if we're running, like you live here, it's going to cover the same time. Because look, if he's going to move here and then he went slow and then here, and this guy going to come in and then pass, they're going to use the same time. From here to here is going to be the same time. Like for example, I want to move from here to there and say, but I'll delay. But the other guy just jumped the same thing and then he jumped, but we drop together. means it's going to be 1 minute to 1 minute for both. Okay? So now, this time is going to be the same. So just say what? T. Okay? And then I'm going to say now, excuse me. Okay. And then after that, I'll say, okay, distance, which is this, equal to 20t, because I can cross multiplication. So distance, which is going to be the same, equal to 20 times t equal to 20t. So this is going to come here. You know what I'm saying? And it's going to help me to get time. So I'm going to say 20t here. 20t equal to 1,6t square. 1,62. Yeah. So now we can solve this as a quadratic. You know what I'm saying? We can solve this as a quadratic. So divided by t. So t and t cancel. So because t and 1t cancel. So 20 equal to 1,6 what? T. Divided by 1,6 divided by 1,6. 20 divided by 1,6. 20 divided by 1,6. Okay, 12,5. Oh, so our time equal 12,5. So time both gonna use gonna be 12,5 seconds. The unit of time is second. Oh, so we got the time. So since I got the time, I can substitute in this equation to get the distance covered. Okay, we substitute here 20 times time. 20 times 12.5. You know what I'm saying? Because that's going to give a distance. So say 20 times time, or time we have 12.5. So time 20. $250. So distance, which is going to be covered by these guys here, 250 meter. Unit of distance in meter. Or can we use this one here? What is that? This one equals 1.6 times t squared. 1.6 t squared. Or I can say distance equal to 1,6. What is our t? Our t equal to 12,5. And what? Square. So you will say 1,6 bracket 12,5 square. 250 still, same thing, 250. So that's the distance. This guy, small car, is going to come and overtake. Now let's go to first question. I think the first question I said already. Scalar and vector quantity. Scalar quantity, it only have a magnitude. But a vector quantity has a magnitude and direction. But we said it, I can say it one more time. Is a type of quantity which has only magnitude. Is a type of quantity which has only magnitude. Which has only magnitude. Magnitude. But not direction. No direction. But not direction. But not direction. I think I explained it before. Direction, a good example, speed, distance. You know what I'm saying? These are scalar quantity. Now let's go for vector quantity. So vector, so scalar only has magnitude, but not direction. But for vector has both magnitude and direction. So vector quantity has both magnitude and direction. Magnitude and direction. A good example, force. Why? Because if I push anything, let's say I'm pushing this stuff up. I'm here, this is my arm here. You know I got big arm, man. So I'm pushing this stuff up. Means I have to use a force. So force, it has, let's say, 4 Newton. But which direction is upward or north? or upward. Means it has a magnitude and direction. So that's a vector quantity. It has both magnitude and direction. The wind is blowing southeast. How does it blow? It blows with the velocity of, let's say, 4 kilometers per hour. Which direction? Northeast. So this is vector quantity because it does have a magnitude and direction. But when you say speed, it does not specify direction. It is 4 kilometers. But if you say to town, means you specify direction, or from to east or home, wherever, then that's not going to be speed anymore. It's going to be velocity. Velocity is a vector quantity. Velocity is a vector quantity. Velocity, vector quantity. Okay. Displacement. Yes, displacement means a distance, but it specifies like maybe from this place to the other one. Means a short direction. Like or the distance I'm going to cover is going to be 5 kilometers, but it's going to be around the cycle, or downward or upward. So that's what we call displacement. Displacement means you specify exactly the distance. Displacement. Excuse me, displacement. Oh, whoa, hey. We done. I'm out, man. Thanks a lot for your time. Peace. I'm out.